We are going to finish this topic on polynomials and rationals by going over inequalities, all right? Talking about polynomial and rational inequalities or nonlinear inequalities. Finding the solution set, that's what we're thinking about. And then when we come back on tomorrow, Wednesday, that's when we start exponential and log functions, okay? So what we're looking at here is we're going to start focused on polynomial inequalities, all right? The easier one of our things to think about, okay? So if I have this polynomial that is graphed right here, right? This is an odd polynomial. We have n behavior going off in opposite directions. And I zoomed in, so the polynomial function is here. The inequality, is here at the top. And I want to know, I want to be able to find out what is the solution set for the polynomial greater than 0. Now, I probably should back up for just a second and say, when I find a solution for an equation, right? When I find a solution for an equation, I get x is equal to some values, right? That's what I get. I get x is equal to -3 and +1. If I was solving this as an equation, right? With equations, we get 1, 2, 3, 4, right? We get actual values. With inequalities, you have to remember I'm looking for the range of values that satisfies the inequality. For an equation, we can find one number, multiple numbers that plug in to make the left equal to the right. In an inequality, we're looking for the range of numbers that make the left greater than the right in this case, right? What values allow the polynomial to be greater than 0? Now, when we have it set equal to 0, this is going to kind of piggyback on sort of what we were doing with our test points, our critical value points. Here, we want to know, and we just want to determine, looking at the function graphically, what values on the x-axis, right, because those are our solution set values, what values cause the function to be positive. So when we're looking at this, especially since we're talking about it in relation to 0, graphically, when I look at a polynomial inequality, I'm looking at, well, what value, where is the graph above the x-axis? Right? Where is the graph above the x-axis? Because that would imply positive values, right? So we can see here that the graph is above the x-axis, starting at -3 up to +1. And then it is above the x-axis again, starting at 1 and moving off into infinity. So I would say any number greater than 1 to infinity, as well as any number in between -3 and 1. Now, why was I so specific about not technically including 1 or -3 in the solution
It
set?
touches the x-axis, it's not above it.
Because of that symbol right there is what y'all are all seeing,
Yes,
right? That says that I'm greater than 0, but not greater than or equal to 0, right? So I can't include those values in my solution set. Now, when we're writing the solution set, we write it in interval notation. So the solution here would be from -3, 1, union 1, infinity. And that's what we're looking at when we solve polynomial or rational inequalities. Graphically, it's pretty easy. You're just looking at the setup here, or you're just looking at it from here. So this is where the function is greater than 0. What if I change the equation, or what if I change the question and I said, what is the solution set for the function less than 0?
Then would it be
Negative infinity to -3.
-infinity to -3, right? -infinity to -3. It's the only portion that would be less than. All right, so graphically, it's pretty easy. This is what we're looking at. These are the solution sets that we're going to be solving for. All right, that's how we write our answers. So here is the first problem that I want to address. This is 9x squared minus 2 is greater than or equal to negative 3x. And I want to solve this, the inequality. I want to graph the solution set, and then I want to express that solution set in interval notation. So there's three things that I want to do here. In order to solve it, first we're going to gather everything up on the same side, right? Isn't that how we solve an equation? All right, so I'm going to gather all the variables up on the same side.
So we just move the 3x over to the side and set it greater than or equal to 0.
I'm going to move the 3x over to the left, and I end up with 9x squared plus 3x minus 2 is greater than or equal to 0. To solve it, we're going to solve it set equal to 0, right? Because I'm interested in where the function actually crosses or touches, right? What the solutions are. So when I solve this, I'm going to do that by factoring. I want to know what the roots are of this polynomial. This factors into 3x plus 2 times 3x minus 1. And because I want to know what it solves to be, when I want to find the roots, I set it equal to 0. Now, did I do that right? I've got negative 3x plus 6x gives me a positive 3. So I checked my middle term to make sure I factored it correctly. I already know that 3 times 3 is 9 and 2 times 1 is negative 2. So it's the middle term again that you have to check to make sure that you factored it right. So those are the factored form. We set each of the factors equal to 0, right? That's the 0 root property. All right, so I'm going to say that 3x plus 2 equals 0. 3x minus 1 is equal to 0. So on the left, 3x is equal to negative 2, or x is equal to negative 2/3. And on the right, 3x is equal to 1, or x is equal to positive 1/3. So that's where the function crosses or touches the x-axis, right? That's where it crosses or touches. What's the multiplicity on these roots that we just found?
2.
Multiplicity for each of their factors would be 1, right? This is the factor here. This is its this is in factored form, right? This is a root. Multiplicity here has a 1, so we would be crossing at each of these places, right? Kind of a refresher on your polynomial graphing. Now, we're going to do our test values. So we do a similar process here, right? I'm going to basically zoom in on this x-axis, and I'm going to write down those x-intercepts. And I am going to test values just like we did before. We're going to test values to the left, in the middle, and to the right of our x-intercepts, which we're going to eventually start calling critical values.
So could we test from the left? Could we test -1?
Yep, we can test -1. You could test
1.5.
-2. You can test whatever you want. Y'all get your calculators out and let's test some points.
Do we set it, do we equal to 0? Or do we do it just like not the greater than or equal?
How do we test points? We're going to put the function into the graphing calculator, and then we're going to use the table
Do
value.
we just set it equal to 0? I
Nope.
mean, it's just it equals. It's not. We don't worry about the greater than or equal to.
I'm just going to put this polynomial 9x squared plus 3x minus 2 on my y1,
Okay.
and I'm going to let my table function, or I'm going to evaluate the function without the table function. So if you don't have a calculator, or if you're just sitting there, do some mental math for your brain to be engaged, still plug some numbers in right there. Integer values, it's a polynomial, multiplication. So to the left of negative 2/3, am I positive or negative?
Be positive.
Okay, so I'm gonna be positive there. In between negative 2/3 and 1/3, I'm what?
Negative.
What'd you say, positive?
Positive to the left of 2/3.
Uh-huh,
You're good.
Oh, there you go.
positive, negative, positive, right? All right, now, since we are dealing with an inequality, and we know from our test values, right, when we've been doing this before, that to the left of negative 2/3, the function itself is positive, so it would be above the x-axis. In between negative 2/3 and positive 1/3, we are below the x-axis because the function itself is negative, it has negative values. And to the right of it, we are positive again. The function that we were concerned with is, where is the function greater than or equal to 0? So in other words, where is the function positive? Where is the function positive? On what interval is the function positive starting from the left?
Negative.
Infinity 2/3.
Negative 2/3.
Thank you. Negative infinity to negative 2/3 bracket, right? Inclusion, including union. Then what? 1/3 to infinity, that's right. So I would have brackets here, wouldn't I? And that's exactly what it would look like if I graphed the solution set. What I just added to my test points. So this part right here would be the interval notation for the solution set. This part that I drew over my graph would have been the graph of the solution set. Right? Okay? That seems fairly easy, right?
So far.
Okay, now you all try that one. There's the steps that I used on the left. Change this, however. Change this to be just less than, no equals to, just less than. What was it? Oh, 0. I wonder where my 1 went. Thank you.
Oh.
There, do that one.
Okay.
Is that a positive? Okay, so -4 -1 is -5. There are not many choices here, are there? When you pick those two factors that way. Right, 4x, right, 4x. So what's another set of factors? One is prime, so it should be fairly easy for you to get that way. So 1/2 times 0. 1. That would be a nervous.
No, there's no possible way. This would be less.
All right, what'd you decide? I tried to trick you. First of all,
No answer.
right, and what does it factor into?
2x minus 1, 2x minus 1.
Correct. Factors into 2x minus 1 times 2x minus 1, or 2x minus 1 squared, giving me a multiplicity of 2, right? An even root. All right, and the way that I changed it up because I wanted to see that this comes down to 1/2 because I know most of y'all graphed it. It comes down to 1/2 and it bounces back off, right? It is never going to be less than 0, so it does not exist, right? There is no solution in the way that that is written. If I had said greater than or equal to, right? If I had kept it as greater than or equal to, which might have been how I had it, right? What if I changed it and I turned it into greater than or equal to? It'd be all real numbers, right? Yeah, because everywhere on there would count because of the less than or because of the equal to portion of that inequality statement. What if I said greater, just greater than? Negative infinity to 1/2, 1/2 to infinity, right? Okay, so you just have to read the inequality symbols. All right. Factoring, right? We got to practice with our factoring. Okay, let's look at rational inequalities. Same concept as what we were looking at before, in that I'm interested in where the function is, in this particular case, positive or above the x-axis. Okay, but we have two things to consider this time. With rational functions, remember, not only do I have solutions or x-intercepts, but I also have asymptotes, and I can never touch an asymptote. So it becomes important for us to probably identify when we're testing those points, which point on that x-axis that I'm zoomed in on is an asymptote and which point is an intercept, because I may not be able to include it, right? All right, so if we're looking here and I want to know, this is the graph of that function up there, and I want to know what is the interval, what is the solution set for the function that is greater than 0, that is positive. So what would that look like? What portion of the graph is above the 0?
-2, 1, 2.
Would I include -2?
No.
No. So it would be a parentheses there at the asymptote, right? Yeah? Okay. So I would have a parentheses here up to, would I include 1?
Yeah.
Yes.
Yes, I would, wouldn't I? Why would I include it?
Because it's equal to 0.
Because it's greater than or equal to 0, right? And then what? There, and then we would have from +2 over to infinity. So we would have that for our solution set, and we would write that. So it would be parentheses -2 to 1, bracket union, parentheses 2, comma, infinity. Right?
Would it be a bracket on the 2?
It's not a bracket at the +2 because that's also an asymptote.
Oh,
So we have to be careful with those when we're looking at rational functions. So this is the same thing that we were doing above in that we're reading it right now. Any questions on how I read that or how y'all read it off to me? All right, so let's look at this. This is good practice for what it was we were just doing the other day, yesterday, as a matter of fact. Okay, So I want to solve this inequality, graph the solution set, and express the answers in interval notation again. And in order to solve this, I need to first make sure everything is on the same side. In other words, I want to make sure that this is, all of my terms are on all of my variable terms are on the same side. They are in this case, right? The rational function is greater than or equal to 0. So that would have been the first step. The second step is to find the roots. How do I find the roots, right? The x-intercepts or the solutions to a rational function.
To find the x-intercepts, you would take the thing in the numerator and set it to 0.
That's right. We're really technically only interested in the numerator because if I set the entire function equal to 0, the denominator disappears every single time, right? Hopefully y'all were figuring that out in the practice that you were gaining. So I would have 3x plus 5 is equal to 0. 3x is equal to -5, or x is equal to -5/3. And the other thing that we're interested in are those vertical asymptotes. And where do the vertical asymptotes come from? The denominator set equal to 0. So I have an x-intercept at -5/3, and I have an asymptote occurring at 3. So when we put this on the graph, or the zoomed in test points, I'm going to put -5/3 as well as 3. But I'm going to typically write over here that this is my x-intercept and this is my asymptote, because I don't want to include, in this particular case, I can include an intercept, but I won't include an asymptote. And I'm just going to rewrite the statement. We're looking for where this function is greater than or equal to 0. So we test points to the left, in the middle, and to the right. And when you do that, you find that we are negative to the left, positive in the middle, and negative in the right, on the right. You agree with that? Yeah? Okay. And I want to know, where is the function greater than or equal to 0, or in other words, where is the function positive? What would my solution set look like then? That's occurring here in between, right? Okay. At -5/3, can I include that in my solution set?
Yes.
Why? Because it's an x-intercept. Can I include 3 in this?
No.
Because it's an asymptote, right? So my interval notation looks like -5/3, comma 3, parentheses. Questions on that? So that's kind of a reminder of what we were doing when we did our rational functions yesterday, right? Solving them, finding the roots, in other words, finding at least the vertical asymptote. Okay. So this one we want to look at now. And this one addresses that first step. So I have the rational function x over x plus 2 is less than 2. And I want to move everything over to the left so that it is basically set equal to 0. So I have x over x plus 2 minus 2 is going to be less than 0. And I left this blank there because we've had practice doing this already. How would I simplify the left-hand side? How do I combine fractions? What do I have to have? Common denominator. And what is the only denominator? X plus 2. So I'm going to multiply 2 by x plus 2 over x plus 2. So that's gonna give me in the numerator, x minus 2 times x plus 2, if I combine it, all over the denominator that we made was common. So I get that. Now I'm gonna simplify the numerator by distributing, getting rid of the parentheses. I have x minus 2x plus minus 4 all over x plus 2. Or in other words, I have a negative x minus 4 over x plus 2 is less than 0. And that is the rational function that I want to work on now. I want to find the roots and I want to find the asymptotes. So we said that the roots occur when the numerator is equal to 0. And we would find out that x is equal to negative 4. The asymptote occurs when the denominator is equal to 0, or at x is equal to negative 2. Now the function that we're looking at here says I want to know where the function is less than 0. So I have my number line, I have negative 4, and I have a negative 2. How does this function behave around negative 4 and negative 2? Plug it in your calculators, tell me what the numbers are. Tell me what the result is, not the numbers, the result. Okay, to the left of negative 4, is it positive or negative?
Negative,
How about in the middle?
plus,
How about to the right?
negative,
Okay, so if I want to know where the function is less than 0, we're looking at values to the left of negative 4 and to the right of negative 2. Can I include negative 4?
No,
Why?
because that's the little greater than or equal to sign doesn't have the line under it.
Even though it's an intercept, I can't include it because of the inequality symbol, right? Okay, and negative 2 is an asymptote anyway, so we wouldn't include it. So the solution set is just negative infinity, negative 4, union, negative 2 to infinity. Okay? Pretty straightforward. It's kind of rehashing what we've done so far as graphing polynomials and rational functions. Do you have questions on this?
Easy money.
Okay, all right. So what I want you to practice on then, there's 4 problems here, all right? The highlighted problems. Solve each inequality algebraically, all right? Graphically, we can read a graph, so that's not what we're practicing here. So I want you to solve these 4 highlighted inequalities. 2 of them are polynomials, 2 of them are rational functions. And if you have questions on them, let me know. What happens if you surround the numerator? That's good enough.
Yeah, it's.
Can I say Have you got anything that's really special in your? You got anything that's special? And you have it? Yeah. You'll have to pass that.
It still doesn't matter.
Negative. I'll do one.
And then that.
Right. That's not No, wait. I don't know.
Only is just
I
like
don't
that.
think about that. For some reason, I think it has to do with. I feel like there's a table in there that's missing. It's just drawing all those.
I think that's what they're supposed to. But it's just like on the first one, that's basically kind of basically what you did.
Because when we did it
Yeah, that's what I'm thinking.
here. Yeah.
I wanted to.
I just, you know how we started out using the graph and just figuring out what the answer was based on the graph? That's not what we're talking about. That's the difference. Okay, first off, I'm gonna turn the clock on. That's
No, you're right.
Yeah. What, you and I just had a.
So you do.
But I think it's right.
Thank you.
See if your graph will help you, you know, support your conclusion. Oh. I was trying to trick you. No. Close.
Whatever we.
So if you do.
No, it just. Yeah, look at that.
You can't include it. Yeah, so.
So that's whatever we do. Even like on our table, you know, if the values between it is positive.
Didn't fall.
Yeah. I did the first one.
19 and 37. All right, cool. Yes, yes, Bobby, sorry. No, Jay, start with the J.
So how would we factor
Factor a GCM out.
two X greater
Correct. Equals 0, right?
Okay. So then we just do like, this was the only one.
Equals 0, because now we want to find the roots.
So then we just only do this one, right? Because this one wouldn't matter.
That one is 0. That root doesn't exist.
But it's just, we don't have to find it or anything, because this one already equals 0. You can find that. So like,
You, okay, so tell me what the answer, tell me what the roots are.
so I know if we did x plus 4 equals 0, right? x would equal -4 at 0.
Okay.
And then 2 x.
Right, but if you don't write that down, are you gonna miss that thing? You would, wouldn't you? What do we think?
That makes sense.
Yeah, it's technically in the field. Parentheses not greater than. If it was greater than equal to, which is.
Zero.
The reason why is. But you.
That would imply.
No, what happens is you have to show that it does.
But when we threw it in here, and I read the picture, that would be all. Algebraic, I want to know what the x-intercepts are, right? I got solved the polynomials, the x-intercepts for x-intercepts and the asymptotes. I test points around it, and then I determine it based on the you had to solve the x-intercepts, right? You had to solve the x-intercepts from the polynomials. And then we draw our test axis, right? Then we draw this. Right, so we had roots, we solved the function for the roots, right? And we'll go back over here. Here's our polynomial.
Right there is everything equal to 0.
Solved it for x. Now x is 1/2, right?
So if it's
And we
0,
test the value on the left and the right to determine where the function is negative or positive. Okay?
So.
Thirty-seven. No, I think it's 1 Okay, so what is this? Is an asymptote? What's this? Those are two asymptotes.
That's
A root, and is it greater, it's greater than or equal to?
No.
So can I include this? Then, okay, so you have it right here, so if I can include the two and I can include this too, then I don't need to separate it out. I would only need to do that if this did not have a
okay.
symbol in there,
How do you, how would
from 1 to infinity.
1 and 2.
Oh,
So if you look at the
Okay.
actual graph, it dips down below just a tad.
Yeah, how we doing?
Or moving on to 23.
Put your test points above it. You know what I'm saying? You chose, you're saying that the interval is only negative. What's -4 in this whole aspect? It's a test point, right? Yeah.
Yeah.
What's your answer? Okay, what happened?
So would that square matter like now if we find 0?
Set it equal to 0 and see. Set the whole thing, x plus 2 raised to the second power. X minus 2, I'm sorry. Square equals 0. And now what would you do to get that square? Remove the square.
Oh, square root.
Yeah, square root both sides. It's the square root of 0.
0.
There you go. So did it really matter? how to ask?
No, it's still 0 either way.
I was about to solve it the wrong way.
Well, go for it.
Actually, good. I need to at least get the ones that you requested.
All right, you got about 10 more minutes. Got to finish this up.
You get minus root 2.
Yeah.
Thirty-seven.
Wait, it has to be less.
Yeah, you're right. Very good.
Oh.
Nope.
That's a very fast.
Oh, it is long without. Without it, they have to put in more work. I know, but I looked at.
You're going from negative here, but I can't. Well,
So why does it just?
negative 3. So my go over here. Negative 3 cubed, right? Plus. 54, negative 54. No, negative positive. Hey, what?
You just like 4 years old.
All right.
Yeah, probably.
Oh, go for it. Go for your mistake.
Sorry.
Negative 3 is not less than negative 4. That's why it's so positive. Right?
So I feel like something's off. Because I put this in the calculator. And I don't, so you said the x-intercept was 0, but there's no x-intercept.
You didn't say the x-intercept.
You said this was 0.
No, I didn't. I said the square root of 0 is 0. Right? So I would have, when I take the square root of both sides, I have x minus 2.
Oh, so I mean
equals
2.
0. Yes.
Oh my God. Oh, I hate my
We almost done? Need another minute?
Another few.
Do you have an iPhone? Whatever. The touch mode? Desmos. Desmos in the touch mode. He's studying some trigonometry or something?
It's like chess.
Oh, I got this, but it also says undefined at -1 as well.
Well, that's because, remember, you have to go back and look at what we're doing. We're doing a rational function here, right? The numerator gives me the x-intercepts.
Yeah.
The denominator gives me vertical asymptotes. So this is where it's undefined because you have a vertical asymptote there.
Yeah, I have it at 1.
Yeah.
More than this, but then it's -1 undefined too.
Are you not, isn't it x squared is equal to 1?
Yes.
Don't I take the square root of both sides?
That'd be.
That would be x is equal to plus or minus 1.
Oh, so it's even 1.
Wait, did she say?
Just look at it, look at shine eyes.
I missed it.
You know, you don't have to do that. I remember. That's the X. That's a negative plus, right?
Nobody else wants to say. Plus, we didn't say the night they could.
Yeah, can't walk on.
Takes now it's about, what do you say, 12 minutes, so. About 140. Stick it to this bars.
No, wait, I never lost. I just lost.
Anyway.
I can.
Scary.
5 hours.
Whoa.
No, that'd be 5 miles in 1 hour. According to my calculations, 5 miles.
Yeah.
But
So you apply for 100.
And then it's 140. It's better. That would be full.
So that changed.
And then-
So
we did it in
It'll take them 28 hours.
If he ran his top speed, or was close to his maximum digits for a straight day, he would still.
Okay, so if we just went off of what your calculation was,
You see,
so
for something,
we are
this is why.
positive,
Learning.
negative.
From 1 to 6.
Answering the answer would actually.
So Ryan, your process,
Right? Don't be confused. I don't even.
See, I was gonna Borealis, but correlate the goals from drone.
Oh, what's it?
Oh.
Do you want to calculate the
I don't know, I don't want to get, I would.
Sure.
Let's get down here. Ask if that was the interest, correct?
he's like, yeah, like,
So this.
Oh, yeah, my eyes.
2.5
No,
hours.
these are.
2.5 hours. Because if you learn how to slow down.
Yes.
All right, let's see.
I don't know how long
Let's go.
No, you
This.
this is 2A, so I know what it is. You want
You're right. I didn't run it. I didn't have an operation.
I struggle on I can factor and use the then I have to try that. Okay? I get that. All right, let me put the answers up here. Hopefully y'all are chugging along.
Oh, yeah, I'm totally jinxing it, bro.
So for number 19, I think that's what I asked you to do. 19 and 23, those are the two solutions that I have, okay? Then I asked you to do 37 and 41. So 41, I did a bunch, yeah, so 41 is, here, we're going from -2 to 9. 41, -2 to 9,
Nine.
feel like I'm playing bingo.
Where'd you get X minus 9 from?
So that was 3x minus 5 over x plus 2 is less than or equal to +2. That was the one I was working here, the one on the left, right? Is everybody paying attention to the one on the left? Okay. And that solution set would be -2 to 9,
Oh, duh.
okay? 37, which we have here. Has a solution set of -infinity to -1, union 1 to infinity. Questions on that?
Probably very, something about 41, how do we get the negative X minus 9? At the numerator.
I'll go back to that in a second.
All right.
Y'all, everybody have this answer? That wants to have this answer? Right? Okay. So when I subtracted 2 to the left, multiplied by the common denominator, and I simplified, I got x minus 9 over x plus 2
Wait,
is less than or equal to 0.
but what, that would be, but what -5 minus 4 be? Oh.
Yeah,
Oh my
-9,
God.
right? -9. Questions?
No, man.
Anybody else have any other questions?
Is this one primarily the?
No. Moving on. All right. No questions over that, is that correct? All right, get out a sheet of paper. Your calculators. Right. All right. So what we're gonna do, I'm gonna